All right, I want to give you two methods for graphing an absolute value function. So the first one here is just using a table of values, which is a method you can use for any function family, and we can always do a table of values. So let's go through this process. So first, we're going to use the form y equals a times the absolute value of x minus h plus k. So our example is y equals negative 1 times the absolute value of x plus 2 plus 3. All right, so in this form, our a value is actually negative 1. So this is negative 1, that's our a value. Our h value is negative 2. Well, how do we get that? Well, the form is x minus h, and we have x plus 2. That means it's x minus negative 2. All right, and then the k value is simply the number outside of the absolute value bars here, so then it's plus 3. So our vertex is negative 2, comma 3. So let's plot that. Left 2, up 3. 1, 2, 3. Excuse me, there's my point. Negative 2, positive 3. All right. Then we are going to put in the axis of symmetry. So I'm just going to use a little dash line here to make my axis of symmetry. All right, that is x equals negative 2. So my axis of symmetry is x equals negative 2. That's what this red dash line is. All right, so that means the vertex is on the axis of symmetry, and then all the other points are off of it. So what we do next is we are going to use a table of value, create the table of value. And the way I like to create it is I like to pick a number of x values either to the right or to the left of negative 2. In this case, I think it's going to be easier if I use x values going to the right. So what's the next value of x right of negative 2? That's right, it's negative 1. So you take number 1, or negative 1, you substitute for x. So negative 1 plus 2 is 1. The absolute value of 1 is 1. Opposite 1 is negative 1. Negative 1 plus 3 is how we got 2. All right, so when I have 1, I get 2. So there's a point. When I substitute 0 for x, I get absolute value of 2, which is 2. Opposite of 2 is negative 2. Negative 2 plus 3 is 1. All right, 0, 1. When I substitute 1 in, I get 1 plus 2 is 3. Absolute value of 3 is 3. Opposite of 3 is negative 3. Negative 3 plus 3 is 0. So I get 0. I plug in 2 for x. I get 2 plus 2 is 4. Absolute value of 4 is 4. 4 times negative 1 is negative 4. Negative 4 plus 3 is negative 1. All right. Now, just to show you, let's say I would have substituted, I don't know, how about negative 3, 4? Let's put in negative 5. If I substitute negative 5 for x, what do I get for y? Negative 5 plus 2 is negative 3. What's the absolute value of negative 3? Positive 3, right? It's the absolute value is the positive distance from 0. So if I have negative 3, it would take the absolute value that I get positive 3. But now, wait a minute, opposite of that, negative 1 times 3 is negative 3, and then negative 3 plus 3 is 0. So if I actually substitute negative 5, I'd actually get 0. So that's 2, 3, 4, 5 right here, that point. All right, I just want to show you that so you can see when you substitute negative values, or if you get negative for inside the absolute value bars, that becomes a positive. All right, next step is after we plot these points on one side, it's really easy to do the other side. I don't need to continue my table of values and be all fancy with a huge table of values. All I have to do is mirror the other side. So see this point here at negative 1 comma 2? It's 1 away from the axis of symmetry, so I go whoop, 1 away to the other side. See this point here, 0, 1, it's 2 away from the axis of symmetry. It's 2 to the right, so I'm going to go 2 to the left. Oh, look at this, the x-intercept here at 1, 0. It's 3 away from the line of symmetry, so I go whoop, 3 to the left of the line of symmetry. That was the point I already had, and I already showed you. How about this one? I have 2, negative 1. It's 4 away from the line of symmetry. So then I go 4 away on the other side of the line of symmetry, and then you have your, connect all your points, and we have our absolute value function equation as a graph. There you go. That's simple as that.